Hi, welcome to my video on Factoring 1, Practice 1C, the final practice in this unit. Factor each completely. Remember, the first rule in factoring is to remove the GCF if there is one. So I see a 2 here. 2 is a factor of 6 and 8, so 2 is the GCF. There's no x common, so we take the 2 out. So 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. Negative 8 divided by 2 is negative 4. This is a trinomial. So GCF is out. So if it's going to go further, it has to be 2 brackets. So x squared is x and x. And we have a product of negative 4. And we have a sum of 3. So the product is negative 4 is 1 times 4 and 2 times 2. So which pair of factors to give me the 3 has to be 1 and 4. 2 and 2 will never give you a 3. And because the product is negative and the sum is positive, so we have to have a negative 1 plus 4. This negative 1 times 4 is negative 4. Add plus 3. And again, first rule in factoring is GCF, so I see an x common. So x is common, so x cubed divided by x is x squared. 5x squared divided by x is 5x. 6x divided by x is 6. And again, we have a trinomial. If it's factorable, it has to be the 2 brackets. So x squared is x and x. And we have a product of 6 and a sum of 5. So the factors are 1 times 6 and 2 times 3. So what pair of factors will give you a 5 has to be 2 and 3. Remember, the product is positive, sum is positive, it has to be 2 positives. So 2 and 3, or you can go 3 and 2. So that's the factorization. And again, we have another, also we got to check, is it in descending order? 4, 3, 2 is in descending order. So I see a 5. 5 is a factor. It ends in a 5 or 0. 5 is the factor, so it's 5x squared is the GCF. So 5x to the 4 divided by 5x squared is x squared. 45x cubed divided by 5x squared is a negative 9x. And we divide right here, we get a 20 plus 20. And if this is going to factor further, again, we have to have the 2 brackets because x squared is x and x. Now we have a product is 20. The sum is in the middle of negative 6. 20 is 1 times 20, even 2 times 10. And I see a 5. So it's a 5 times 4. And which pair gives me a 9? So that'll never give me a 9. That'll never, so it has to be 5 and 4. But the product is positive and the sum is negative. It has to be 2 negatives. So we have to have a 5 and a 4. Multiply. 20. Add. Negative 9. Perfect. D. Again, we descending order, it is, yes. So we move 3 is a factor of 3 and 36, yep, and we have an x. So we have to take the negative out, 3x. So that gives us x squared. 3x squared divided by negative 3x is negative x. And 36 divided by negative 3x is a negative 12. And again, we have trinomial. And if it's going to factor, it has to be x and x. And the product, again, review, make sure. I always like doing this just to make sure. Product is negative 12, sum is negative 1. So 1 times 12, 2 times 6, 3 times 4. Which pair gives me a 1? Because it's a negative, we will have a plus and a minus. So which pair will give me a 1? Because we have a plus and minus, they differ. So that differs by 11 or a negative 11. This differs by 4 or negative 4. So that has to be 3 and 4. But the 3 and the 4, got to be careful. it has to be, the larger number has to be negative. So 4 is negative, 3 is positive. Multiply. 3 times negative 4 is negative 12. Add 3 and negative 4, negative 1. Perfect. E, descending order. We have to have a 5, then a 4, and then a 3. So we get x to the 5 plus x to the 4 minus 42x cubed. So x is common, but we take the smaller one, which is 3. So take it out. So x to the 5 divided by x cubed is x squared. x4 divided by x cubed is plus x. Negative 42x cubed divided by x cubed is negative 42. And again, if it's going to go further, because we have a trinomial, this is a quadratic, 2 factors, so it's x and x. And the product is on the end, which is negative 42. And the sum is in the middle of a plus 1. 42 is 1 times 42. 2 is even, or 42 is even, so it's a 21. And I see a 3, so 3 times 3 14. And I see a 7, so 7 times 6. See, if you look around, the factors of 14 will also be factors of 42. 14 got a 2 and a 7. Because I got a 21, 21 got a 7, yes, and a 3. So you see a 6 and a 3. Again, the factors of the 21 are also factors of the 42. So we got a negative, so it's again I just go plus minus automatically, and we differ by 1. So because they're plus and minus, they're going to subtract. So this is 42. This is 19. This is 11. So it must be 7 and 6. But the 7, because it's positive 1, the 7 has to be positive, and the 6 is negative. Multiply negative 42, add 1. Great review, factoring. But let's look at some other parts of the factory. Which trinomial is a perfect square? A perfect square trinomial has the first and the last terms squares, some number squared. And if you multiply them and double them, you get a middle term, but it has to be a plus at the end. This has to be a plus. If it's not a plus, it won't be, because they're perfect squares. This number has to be a plus, so this is not a perfect square because that's a minus, and that's not a perfect square. So to be a perfect square, the first thing you look for is a plus at the end. If it has a plus at the end, then you look at the square root of x squared is x. The square root of 4 is 2. So if you double their product, the product of 2 and x is 2x. The product is 4x in the middle. So this can be a plus or a minus. Again, that's square root of 4 is 2. Square root of x squared is x. And their product is 2x double 4x. So this is not a perfect square trinomial. So let's look at this one. Square root. It has a plus at the end. Yes. Okay. So square root of x squared is x. Square root of 16 is 4. Product is 4x, and you double it. You get 8x. So this is a perfect square trinomial. What that means, that this trinomial is made up the same two binomials being squared, which we'll look at now, coming up in the next page. Factor each completely. So there's several ways we can do this. We can factor it like normal. Like we could say that there's no GCF, so the product is 25 and the sum is negative 10. So that's 1 times 25, or it's 5 times 5. So we have a bracket, double brackets, x squared, x times x is x squared. Now, what pair of factors will give me a 10? So the product is positive, so we got 2 pluses or 2 minuses. but we got a negative in the middle. So it's 2 pluses or 2 minuses, so it's 2 minuses. So what pair of factors will give me a 10? 5 and 5. 1 and 25 won't give me a 10. 5 and 5. So that's x minus 5 squared. So x minus 5 times x minus 5 is x minus 5 squared. That means this is a perfect square trinomial. How do we know? Well, let's look at it. This is a plus, perfect. This x squared, square root of x squared is x. The square root of 25 is 5. And we double it. So when we double it, we get 10x, which is in the middle. So that's a perfect square trinomial. Now, let's do the next one. It's in descending order. I see a 7, 42, 6, and that's a 9. So I see a 7 is GCF and x, because x is common. And 7x cubed divided by 7x is x squared. 42x squared divided by 7x is 6x. And 63x divided by 7x is a plus 9. So this is 7x, and if this is factorable further, x and x. And the product is 9. The sum is 6. So 1 times 9, 3 times 3. And because the product is positive and the sum is positive, we got 2 pluses. And the factors are 3 and 3. So that's 7x times x plus 3 squared. Again, this is a perfect square trinomial. Why? Because it ends in a plus. The square root of x squared is x. The square root of 9 is 3. And we double it. So that gives us a 6x, which is what's in the middle. So that's a perfect square trinomial, which means it's going to be the binomial squared. And that's true. We work it out both ways. And let's look at this one. And we have descending order. So we got a negative x to the 4 plus 20x cubed minus 100x squared. That's the descending order. And I see a negative in the first term, take it out. And I see x squared. The smallest power of x is x squared. So a negative divided by negative positive, so that's an x squared. 20x cubed divided by negative x squared is negative 20x. And a negative divided by negative is positive. 100 divided by 1 is 100. And x squared divided by x squared is 1. And if this is factorable, is x and x. So we have a product of 100, and we have a sum of negative 20. 100 is 1 times 100. It's even, so it's 2 times 50. 50 got a 5, or 100 got a 5, so that's a 20. I see a 10, so it's 10 times 10. And I 50 got a 25, so it's 4 times 25. A lot of factors. But which pair of factors will, again, because it's a plus, because the product is positive and the sum is negative, we have to have 2 negatives. So what pair of factors will add? There are 2 negatives that are going to add up to give me a 20. And 10 and 10. That's 101, that's 52, that's 25, that's 29. So 10 and 10. So this is a negative x squared and x minus 10 squared. That 2 is supposed to be up there. And again, this is a perfect square trinomial. Why? Because the square root of x squared is an x, that's a 10. And double their product, so 10x doubled is 20x. So that's a perfect square trinomial, which is x minus 10 being squared, which is a binomial squared. Number 4, which binomial is the difference of 2 squares? And we're getting the difference of 2 squares over the set of integers. So this is a difference. Difference means you've got to subtract. So this is no, because that's a plus, and that's a no. This is the sum of two squares. That's an x being squared and 4 being squared. That's an x being squared and a 2 being squared. So this is the sum of two squares, not the difference. So it's one of these two. This is integers. So there's no two integers will multiply to give you a 5 that are the same. The difference of two squares has to be the same terms with a plus and minus. So this can't work. So, but this one can. Difference of two squares, this is an x being squared, and this is a 9 being squared. So this is the subtraction of two squares. And this, when you recognize that, this is easy to factor. And let's go through a few. Let's just look at this one for example. I didn't ask you to factor, but if this is the difference of two squares, x squared, 9 squared, and that's the difference, it'll turn out to be this way. It'll be x and x. It'll be 9 and 9. Because of the difference, the product is negative 81, so it has to be a plus and a minus. So if we did the FOIL on these two, you would get this. So that's the difference of two squares. If you got the difference of two squares, there'll be a plus and a minus of the same terms. Let's factor this one completely. So we got 11x cubed minus 44x. I see 11 in both of these, and I see an x. So we take it out. I see an x squared minus 4 when I divide. Notice that this is x being squared and 2 being squared. So this is the difference of two squares. So automatically, you have an x and an x. You have because it's a minus, we got a plus and a minus, a 2 and a 2. Remember, if you look at doing the FOIL on this, and I'll just do that to show you. FOIL on this, just these two binomials. First term is x squared. Last is negative 2x. Inside is a plus 2x, sorry. First, outside. The outside is negative 2x. Inside is 2x. And the last is negative 4. So notice that these cancel to give you 0. So that's the difference of two squares when you recognize it. They'll be the same terms with a plus minus. And right here we got to go with descending order. So it's negative 8x to the 5 plus. So always put it in descending order. It makes it easier to do. And the next, after you do descending order, you take out the GCF. I see a negative in the first term, and I see 8 nines. I see 8 is a GCF and an x cubed. X is common. That gives us an x squared when we divide. Divide here, and I get a negative 8 nines or 72. And this is, again, this is x being squared and 3 being squared. So that's the difference of two squares. Automatically, you can go x and x. Square root of 9 is 3, and it's a plus and a minus. That's the difference of two squares. Notice the middle, there's no x in the middle here. So that means the sum is 0, which is what these two will be. When you do outside, inside, you get negative 3x and 3x, so the sum is 0. Let's continue. Which one below is the sum of two squares over the integers? The sum of two squares. Sum means add. So we have it here and here and here. No, this is the difference of two squares. That's x squared and 2 squared. So that's x being squared and 2 being squared. So that's the difference of two squares. So it's not the sum. So the sum of two squares over the integers. So this is x being squared, but the 6, what number do you square to give you 6? We haven't learned this yet. So this is not over the integers. So no for this one. This is a 2x being squared. And this is plus. We have a 3 being squared. But we have a y. The y is not squared. So this is a no. If it's x squared, it's got to be a y squared. So this is the one that works. This is the sum of two squares. So notice this is 6x being squared plus 11. So this is the sum of two squares. So this is the correct answer right here. And this one is a no because of the difference of two squares. Now, the last part of the factoring. Factoring over the rational numbers, something that I like to do. Rational numbers are fractions, so we have to remove the fraction here. And so that means the LCD, least common denominator for 2 and 5 is 10. So what I do, I put both over 10. So 2 times 5 is 10, 5 times 1. So that's the equivalent, and we got to do a 10 here. 2 times 5 is 10, 2 times 2 is 4. So now I see 10 is common on the bottom and 1 is common on the top. So you take 1/10 out of this, we get a 5x, and you take a 1/10 out of this, we get a 4. So that's factoring by remove over the rational numbers. And here we have an LCD of 4 and 8 is 8. So I need an 8 as my denominator. 2 times 4, 2 times 3. And this is already LCD of 8. Now what do I see? I see an 8 on the bottom, and I see an x. But 6 and 5 only have a 1 in common. So we take out, what do we, 1/8, but I need a 6. 6 times 1/8 is 6/8. And we have an x. X squared divided by x is x. And we have 5/8, 8 is there, so 1 into 5 goes 5. And we have two more to do. I see a negative. First, it's in descending order, I have a negative. So I take the negative out. But before I take the negative out, let's change these to the same denominators. LCD is 3, so that's okay. The LCD here is 3, so that's 3 over 1. So we multiply by 3 times 1 is 3. 3 times 3 is 9. So 9 over 3 is the same as 3. Now I take the negative. 3 is on the bottom, and between the common factor between 1 and 9 is 1. So take it out. Take the negative 1/3 out, and I get x squared. Negative 1/3 here is negative 9. Check it, multiply back. Negative 1/3 times x squared, perfect. Negative 1 squared times negative 9, 9 over 3, which is a 3. And we have the difference of two squares. We have a x being squared, and we have a 3 being squared. And because it's a minus, that's a plus and a minus, difference of two squares. And the last one on this review, we have to go with descending order. So we got 1/5 x to the 4th minus 13 over 5x cubed minus 6x squared. So we got 4, 3, and 2, everything. So let's put them all over the same denominator. The LCD is 5. So we got 1/5 x. We got 13 over 5x cubed. And we got a 5 on the bottom. So 5 times 1 is 5. 5 times 6 is 30. So 30 over 5. It's the same as 6. Now we have x is common. The smallest exponent is 2. And we got a denominator of 5. And there's nothing common between, only a 1. So let's take that out. Let's see what we got. 1/5 divided by 1/5 is 1. So we got x squared. And right here we got 1/5. 13 over 5 divided by 1/5 is 13. And we need the x. x cubed divided by x squared is x. And right here we got a 30. X squared divided by x squared is 1. And 30 over 5 divided by 1/5, we need the 30, negative 30. And this is factorable, hopefully, as if not, we won't be able to do it as two binomials mean squared. X squared is x and x. And just move it down here. We have a product of negative 30. We have a sum of negative 13. So it's 1 times 30, 2 times 15, and 3 times 10. And we have a 10 got a 5, so the 5 into 30 equals 6. So we have all these factors. But because the product is negative, we would have a plus and a minus. Because the product is negative, we got a plus and a minus. So that means the factors are going to differ by 13. And which ones differ by 13? That's a 29. There it is right there. 2 and 15. This 3 and 10 differs by 7. And 5 and 6 differs by 1. Remember, because the product is negative, the factors will differ. If the product is positive, then the factors would add. Now, so 15 and 2. So because that's a negative 13, the larger number is negative. So 15 is negative, 2 is positive. Or negative 15 and 2. 2 is going to be the positive. So multiply 2, negative 15, negative 30, add negative 13. So that's a total review of the factoring that you do in the early stages. And again, if you like my video, click on the like button and the subscribe button. And I'd like to thank you for viewing my video and hope the video helped you. Bye-bye.